It is often said that procrastination is the enemy of progress. Those who keep on saying that I will start tomorrow, I will start day after tomorrow, we all know that they are never going to start anything. Whereas those who are serious about their career, who are serious about upskilling themselves, they will somehow find a way from their so-called busy life to take out time and upskill themselves. On behalf of whole DataSense team, I welcome you all to this Python full course, where we will progress from writing your first Python code to writing advanced ML and data engineering code in 50 days. Over the next 50 days, I will walk you through across all the difficult Python concepts and try to explain them in the most easy format possible. Your task is to watch the videos, complete the assignments which I provide, and complete the challenge questions which are present if you want to stay alive in this particular group. It's a journey where people who do not take participation will eventually be removed from the group. So make sure you actively participate, actively listen to everything. Before proceeding ahead, I would like to just mention one thing. Over my career, I have seen so many people failing in Python interviews. They are not able to upskill themselves, and eventually they give the reason that the course was expensive. I could not find the right course. I was busy, so I could not prepare. And when the result comes, they start always cribbing about these particular or these or any other reason. At DataSense, we have eliminated all of these reasons because we are providing this absolutely free. Then it is driven by you, not by me, because if you will not participate, you will not be there, right? So it will be totally driven by you. So it's a one-time opportunity that you can grab from both of your hands. So without wasting much time, I will start with the introduction of the video, that what all is there in video for you, so that we can start working on the concepts. Okay, so let's start with what do we have in this video for you. So we will start our video first of all with OOPS programming, that is object-oriented programming, because we all know that Python is an object-oriented programming. Be it Python, be it Java, or there are like lot of programs which are object-oriented. So what do we mean by object-oriented? You need to, so no one is going to ask you this in question, but you should know, because when you will be coding, you will understand, okay, why we are doing it in this format, because Python coding is little bit different from SQL. So that's why you need to know. After this, we will start with the definition of Python. So basically, Python program, where did it get its name from? Why is it called Python? Is it something to do with snakes, or is it something else? So I will walk you through that. So once this is done, I will compare how Python is different with SQL, because I know most of you are coming after a background in SQL. So you might have some coding mindset of SQL. So how Python is different from SQL, what are its advantages, what are various things which are present in Python which are not in SQL. And after this, we will finish this video with our first concept, that is lists, which is the list and data structure. So I'll walk you through what all data structures are present in Python, which we will be covering. And I will start with the first data structure, that is list. In list, I'll explain you what is list, what are its attributes, some of the examples, and what all things you should be knowing. So these are the 4 topics of discussion in this video. So let's deep dive into the object-oriented programming, or OOPS for short. Many of the popular programming languages today like Python, Java, and C# are based on OOP principles. To understand this concept better, let's walk through a simple relatable story. Imagine there is a huge factory that specializes in producing cars. To build these cars, the factory first needs a blueprint. A blueprint is what? A detailed plan of what every car will look like. This blueprint includes attributes like 4 tires, 6 windows, 2 front seats, and 1 back seat. This is essentially the factory's template for a car. Now, let's say a company like BMW places an order of 500 cars. Thanks to this blueprint, the factory can easily produce 500 cars that are identical in their specifications. Each car that comes off the production line is an instance or object of the original car blueprint. These cars can perform actions like stopping, accelerating, decelerating, or anything, right? In OOP terms, these are called methods. So overall, to summarize, the factory creates a blueprint or class called car here. Then it produces 500 cars, each an object of the car class, which share all the properties of the car, and now each car can perform various action or methods such as stopping or accelerating. So in OOPS programming, we will encounter classes, objects, and methods, and the general way to write a code in this format is class.object.method. So let us try to understand OOPS with two more real-time examples. So first of all, let's talk about a restaurant. For example, let's say there is a restaurant. Okay, so what happens in restaurant? There are for example McDonald's. Okay, there is a McDonald's. So McDonald's has three categories of products. So it produces either burgers, it produces fries, or it produces, for example, soft drinks. Let's say it produces soft drinks. It produces three type of things. So what it will do is that, for example, now we know that McDonald's burgers are famous because they are consistent across all globe, right? I mean, if in India you go anywhere, you'll find same taste in McDonald's burgers. So what do? They create an architecture. They create a blueprint. For example, whatever ingredients, ingredient 1, ingredient 2, ingredient 3, whatever is going inside in whatever proportion, everything is fixed initially only. So that doesn't matter whoever is making these McDonald's burgers, they come out to be of the same taste. So this is called the architecture. You call architecture, or you call it a class of burgers. You can call it a class of burgers. A class of burgers. So they have created an architecture or a blueprint. Now what happens that now in any restaurant, a customer come and they start producing burgers. For example, B1, B2, B3. So what are these burgers? These are objects. Burgers. These burgers are objects of the class burgers. Okay. So there's a class burger and we have multiple objects produced through this architecture. And through this these burgers, they have multiple methods. They can either be eaten, okay, or they can be stored in a fridge, or if someone can throw it away, someone can throw them away. Okay, so how will you write this thing in Python code? You will write down class burger, okay, then dot, then we have object. You can choose any object. So b1 dot method. For example, let's say someone has to eat. So this is how Python programming is built. Wherever you see something like this, so Python programming is built like this only, OOP structure. You have a.b.c. So this is your class, this is your object, and this is your method. This is your method, or you can say attribute or anything. Okay, so this is how things are. Now you can vary. Suppose you don't want to eat, on the same object you can apply stored as well. Okay, I don't want to eat, I will store it. So this is the concept of OOPS programming through the concept of burgers. Now let us try to understand this with a more recent example, so that this concept is totally ingrained in your mind. Nowadays with the today we all use ChatGPT, for example, right? In today's world, every one of us uses ChatGPT. So ChatGPT is an LLM. So we use ChatGPT. ChatGPT is an LLM which is based on a model called GPT. It is a transformer. You don't need to know everything, but this is based on transformer. This is called an LLM. Okay. Now what does it do? It's a question answer chatbot that can answer anything. This is the architecture, that it is a question answer application which can answer any question that you ask ChatGPT. Now what happens that a lot of companies, they have created their AI apps. For example, let's say there is a lawyer based company. which provides legal remedies. So what it does, so let's say there is a law firm. What there is a medical, there is a medical, or you can say there's a medical usage, for example. Okay, and then let's say there is a fitness, there's a fitness application. Okay, so there are three applications. One is based on law, one is based on medical, one is fitness. So what each of these do is they train this. Presently, this chatbot will answer generic things. So what they do, they actually train this particular model on their law data. For example, they can train the ChatGPT on their own law data, on historical data of law, so that whenever a user comes on their website and it asks question, he gets law related queries. He get queries related to law or law queries. Okay, so he can get these type of queries. A person, suppose he wants a medical advice, he comes on this app, on this application, which is based on GPT, and it has trained itself on the medical data. Okay, and it provides medical precautions, medical advice, precautions. Okay, similarly, this fitness, it provides, for example, fitness routines. It tells you fitness goals, fitness plans, and all that, fitness routines. So now tell me, so what is the case here? We have a class. So this is a class which is the general architecture. Okay, these all are application. This is application 1, which is present on maybe Play Store or App Store. This is application 2, this is application 3. Okay, so what are these? These are objects. These are objects, and they are doing their one is providing law queries, one is answering medical questions, one is answering fitness routines, right? So these are called methods. So all these have the same the attribute of every object is same. They are a Q&A bot, but they answer different things. So class.object.method. So this is how companies are using use LLM for their various AI purposes, right? And this is the concept of OOPS. It also works in a similar fashion. So I hope the concept of OOPS is clear to you. Now I will explain the OOPS through programming. A basic example I will share with you through programming, so that you understand this even more in depth. So let me walk you through a simple code, or how class is built and how objects are assigned inside a class. So let us say I have to build a class that, for example, let us say a class. After that, so whenever you assign a class name, you have to start with a capital letter. Okay, so let's say I assign a class known as cars. So after this, we have to provide a semicolon like this. Now after this, I need to provide some attributes. So not cars, it has to be cars. Okay, now a car can have multiple attributes. So let me define few of the let me define few of the attributes. So for example, I can name it model. Model is equal to, I can type it to be 1994. Let's say these cars which I'm building are of the year 1994. Okay, I can say that these cars have color equal to red. So presently I have given two attributes to this class, cars. Okay, now what happens that my class is created. Now I need to create objects. So my blueprint is created. I will have cars of 1994 model which are red. Now, so my factory is prepared. Technically my factory is prepared. Now I have to manufacture cars. So for each car is called an object. So I will say C1, which is my first object. So what I will need to do, I will need to assign it the architecture of this car. So what I will do, I will do cars, which is this particular name. Okay, cars, and I will do this close brackets. So now what this is doing now, it is creating an object of C1 type, whose name is C1, and it is of cars type. Now if I want to check that, now tell me, what will be the color of this car C1? it should be red, because by default we have given that all the color of any car in this class car should be red. So if I do, let's say, a print statement, print C1 dot color, okay, so I should get red as answer. So I am getting red answer. Now similarly, let's say if I print C1 dot model, so its model will be 1994. So let's say I print this, so I've got the model to be 1994. So this is how an object is built using cars. Using a so we have a class and we built a model. Of course, there are a lot of things here which you can do, like you may not provide value here, it can take value by default, like those things are there. But my objective is just to show you class is creating an architecture, and after that C1 is assigning and creating an instance or creating an object. So this is that, and after that color is a method of that car. So so there was a class called car and there was an object known as C1, and object known as C1, and then there were attributes. So what were its attributes? Model and color. So this is how Python programming language or any other OOPS programming language is built. Now after this I'll explain you through one of the major example, scikit-learn, that when we use a machine learning model, how we use object, class and methods in that. So let us see the Python libraries which are present. For example, you all must have heard somewhat Python has a library called scikit-learn. 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 This library we will use in later lectures because this is a machine learning library. So we will see how does it uses OOPS, for example. So this scikit-learn library, it is called a module. This is called a module. Okay. Similarly, there are a lot of modules. There is for example, Python has NumPy. NumPy, it is there. There is pandas. There is scikit-learn. There is seaborn. There are like lot of modules present in Python. So what is there? So scikit-learn is the. So this is not a class. Scikit-learn is just a module. So this is just a module. Now scikit-learn has, so I will talk about couple of classes. It has one of the class which is called linear model, basically linear model. It has a class called linear model. And it also has a class called tree model. Tree model. So these are the classes which are present inside scikit-learn module. Now these classes have multiple. So this is used for regression. This is used for decision trees. So each of these classes have different objects. For example, this has a linear regression. Linear regression. So this has a, let me just zoom out a little bit. Okay. So yeah, so let us say, yeah, so this is a linear regression object, linear model. Then it also has a logistic regression. Similarly, this tree model also has different so for example, this is a decision tree object. We will talk about these algorithms later, but decision tree, just understand. This is a decision tree object. This also has like random forest. Okay. So what are these? These are objects. These all are objects. what we are seeing here. This is an object, this is an object, this is an object of class linear model. These are of the objects of class tree model. Now let's talk about what all methods do these objects have, right? So for example, a linear model, a linear regression, it can have multiple things. For example, it has a method of fit, where you fit a linear regression on a data set. It has a method of predict, where you have to predict a value, okay? And then also it has some intercept. So similarly, logistic regression also has these above methods. It has a fit, it has a predict, it has an intercept. Same with decision tree, it has a fit, intercept, and there are few other. So these are called the methods. So when you write down these codes in your for example Python, so how do we write the code? So we do that we import the module, then we create an object from linear model. So we create an object, let's say LR, linear regression, is equal to linear regression. So linear regression is a okay. So we create an instance through this, and after this we fit this LR to various methods. So we either .lr.fit or we do lr.predict. So these are called classes. So this is a class. This is a class. This is an object. And this is method. Similarly, there are multiple libraries inside Python, I would say. So you can basically check that. So now I will move towards the coding part of this particular thing. So now we will apply the concept of OOPS in our a basic simple linear regression model, where we will try to predict a value. Okay, so what do we need to do? We need to first of all create some class. Remember, so focus on class, object and method. You won't understand linear regression if you don't know. That's totally fine. I'm not here to teach you linear regression today. I'm just here to teach you what are object, what are method, what are class. Okay, so for example, first of all we build a class. So what do we do to get the class? We import the models which are present. So we import numpy as np. Okay, so this is a module. So numpy is a module. So first of all, I'll be importing this is a module. This is not a class. So numpy is not a class. Numpy is a module. Similarly, we will import so from scikit-learn. So for example, from sklearn dot linear underscore model, import linear regression. So remember, a class always has a capital starting. So you will never the nomenclature is like this, that a class, any class will always have capital starting. Okay, so we have imported our modules right now. So this is one of my object, one of my class, that is linear regression. So what will I do now? I have to create objects. Okay, now to create objects from these classes, create objects from these classes. So what will I do? So first of all, from numpy I'll create my normal data set. So I'll create a normal array x which is equal to np dot array. Now array is a class. So array is a class inside module numpy. Okay, so I will create an array. So how will that array look like? Is that, for let's say this is 1, this is 2, and let's say this is 3, this is 4, this is 5, and this is, so this okay, we created a list of arrays, and this is what I'm having. So let me try to print x. So x is an object of class array. So this is how you will say it. Okay, so I have got an object. Now if you know, when you're creating a data set for machine learning, there has to be an independent data set, independent variables. This was independent variables. Now I need to create a dependent variable as well. For example, let's say I create y equal to, so this is also an object, y equal to np dot array, and after this we will create the values inside it. So 2, 4, 6, 8, 10. So what are these values? These are the corresponding. So if x is 1, y is 2. If x is 2, y is 4. If x is 3, y is 6. If x is 4, y is 8. And if x is 5, y is 10. These are those kind of values. Okay. So I have created this. Now let me print y as well. Let me check what is it coming. So if we check, we have these things. So we have x and we have y. So I have created two objects of array class. There is an object x, there is an object y of class array. So I hope it is clear from here. Now I will create an object of class linear regression. So what I will do, model, which is my name, I will do linear regression. Okay, linear regression. And I will create, so how to remember how to create a, so whenever we are having a class and you have to create an object, so we need to name the object, for example, like this, and create a bracket like this after this. So it shows that linear regression is a class and we are creating an instance or an object of class linear regression. Okay, so model is an object. Now you know that if there is a class, there is an object, then there will be a method. So what will we do? We will do model dot fit. We will fit linear regression model on our data set. So which were our x and y. Okay. So now if I run this particular code, I see linear regression model has been run. Now I will create a new object, that is prediction. So now I have to predict value for some. So what has happened? It has created a linear regression between these values. Now I have to predict for a new value. For example, let's say enter 7 or 10. So will it create a value for me? So what I will do, prediction equal to, I'll do model dot predict. Now predict is another method of class linear regression. Okay, so predict, and then I will do np dot array. I have to pass a value to this. Okay, so what I will do, I'll create a list inside it, 6. Let's say I am checking for the value 6. This is a basic linear regression model that I am doing. Now if I print prediction, let's see what comes. So I get 12, right? So because for it was into 2 technically. So 1 into 2, 2 into 2, 3 into 2, similarly 6 into 2. So this is how my prediction is. So overall, my objective is not to teach you linear regression right now. It is to teach you what are the classes here. So let's talk about what are the classes here. Here the classes are linear regression, and we see array. Okay, the numpy.array. Array is a class. Okay, after this we have an object. So what all objects have we created inside? So the object we created an x, we created a y, and we created a model, and we created this prediction, right? So we created this prediction, and after this we created 2 methods. So what are all the methods that we used in our code so far? So methods are, I will say, first of all, we used a fit, and we used predict. We used a predict here. So these 2 values are the methods that we have used. So I hope this is clear. What are methods, what are objects, what are classes, because we will be requiring these when we build codes. So just try to understand. In Python you will see codes like a.b.c. So it is always class.object.method. So you should know what all methods a particular object is having, or what are elements a class has. You will not remember everything, so don't worry about that. But whenever you build a habit, whenever you read a Python code, you should be able to tell, okay, this is a class, this is an object, this could be a possible attribute. You do not need to remember all the methods, and everything is available on internet. So you don't need to remember, like, muck up everything, right? But just understand for example, when you see a SQL code, you understand I'm doing a select statement, or I'm doing a window function, or I'm doing something else. Similarly, you should understand in Python as well how the syntax is written. So that was the objective to explain through this video. So I hope the concept of oops is clear to you now. You don't need to bother about the code that I just did, right? We will do that later on once we understand Python more. So just understand class, method, and object. Okay, so now let's move to our next topic, that is Python versus SQL. But before that, I would like to ask you one thing, that do you guys know why Python is named as Python? For example, let's say SQL is named as SQL because it means structured query language. So by default, it means that, okay, this is something to do with databases, right? But Python, like it's a snake. So how is it related to a coding language? So I won't waste much time here. So if you go to this Python, they have mentioned it very clearly that the person who developed Python, 𝐘𝐨𝐿, I don't know how to spell it. He was reading the published scripts from Monty Python's Flying Circus, a BBC comedy series, and then he decided that a name that was short, unique, and slightly mysterious. So he decided to call the language Python. So there is no specific reason I would say that it is called. For example, let me open this. He was watching this BBC series. It was he watched it, and based on this, he created the name Python. So there is no formal, no big scientific reason that why is this called as Python and not some other language, right? Python has nothing to do with snake. It is just a reference from somewhere. Okay, so coming back to SQL versus Python. Now let's start. So there, if I go from history, right, there were three types of languages. So first of all, before this all started, there were statements known as procedural languages. Procedural languages, which is your SQL. After that arrived functions. And after that arrived oops. So this is a timeline. So what happened that procedural language are codes where you write everything. There are no shortcuts. I mean, you just write whatever you need to code. You just write down everything. For example, let us say I have a data set. I want to print number of customers who were booked in 2004 and number of customers who were booked in 2005. So what we used to do earlier, select star from table where year equal to 2005. Okay, and we just copy this statement again and again. Now let's say I want to print value for 2000 value of years, 2000 years. So I need to copy this statement 2000 times, right? Because there was no concept of function stored procedures earlier on. Now this becomes very daunting because it's a very simple query that is being repeated multiple times, where you are just changing the value of year. Then came the concept of function. So the concept of function said that, okay, if you have a repetitive thing, okay, for example, if you have a repetitive thing, just like there, that year, so you create a function like this, def, let's say year, and you pass an input value, for example, let's say data, and you pass the filter that you want to do, okay, and you just write down one code, that select star from this table, and that's it. After that, whenever you pass me any value, I will print you that. So you don't need to, here you just write the code one time. Here you have to write it 2000 times. Okay. So do you see the change in the shift, basically what is happening? Earlier we used to do lot of redundancy. If I have talk about redundancy was lot earlier. It was decreasing. And after function, the concept of oops came, which reduced by calling class, object and method, we reduced redundancy even further. So that's how we see that SQL is a procedural language. So SQL lies here and Python lies here. So Python is by far I mean, it's very advanced than SQL. So this is the fundamental difference. But there is one more difference beyond this, which I will speak about. Just let me clear my board. Okay. So another major difference is that SQL and Python. SQL is only used for relational databases. So the first thing is that it is only used for relational databases. So what is a relational database? Like, it is just like a data that is in this format. A data that is in this format, XY. So you have this kind of data, you have rows and you have columns. So this is a relational database, right? So SQL is used only for this. SQL cannot take any other thing. Whereas a Python can take a JSON file, it can take an audio file, it can take an image, it can take any type of data. Python can take any data. So by default, you can see that, I mean, Python of course is it has broad scope that as compared to SQL. SQL is primarily used only for querying languages, querying relational databases, nothing else. Okay, then comes Python provides connectivity to API, and that is why it is used for building web applications, and like website development, lot of. Whereas SQL has nothing like that. So there's nothing that SQL can do and Python cannot do. Okay. So these are the two major differences between SQL and Python, and that's why it is very crucial to learn Python even if you are data scientists or data engineers, because lot of ETL, ML stuff which are done in Python, it is not possible in SQL at all. So that's why it becomes very imperative. SQL is very good for data analysis. Yes, it is good because most of the data is relational database. But think about, for example, you're working on audio data or an image data, image classification. You cannot use SQL here, right? You need to use Python there. So Python is a universal language, that I would say. So that's the basic difference between Python and SQL. Now, enough of the theory part. We will switch to our first concept, that is data structures, and in that we will talk about lists.